Hello viewers, today we are going to solve problem number 6 part 1 under the topic Bode plot. And the problem is sketch the Bode plot for the open loop transfer function g of s into h of s which is equal to given by this expression. So we need to draw the magnitude plot and phase plot for the given expression. So this is our given expression. So here when you look at the expression, our expression should be always in the format of 1 plus term. Okay. So here this is okay for us because we are having 1 plus yes, it's okay. But when you look at this term, here we are having 4 plus yes, it should not be. Okay. We should always have only 1 plus terms. So here we are going to rearrange the expression. So 40 divided by s into 1 plus s. So from this expression I had taken the number 4 outside. When I had taken number 4 outside, the remaining terms will be s by 4 plus 4 by 4 becomes 1 here. Right. Now this 40 and 4 cancels each other. Here we are getting the answer as 10. So in the next step, g of s into h of s is given by 10 divided by s into 1 plus s, 1 plus s by 4 here. So the next step, we are going to rewrite this s as j omega. So when you write s as j omega, we are having an expression like this. You see 10 by j omega, 1 plus j omega and 1 plus 1 by 4 is nothing but 0.25. So here I am writing it as 0.25 j omega. Right. Now we are going for magnitude plot. So the first step is finding corner frequencies. So how to find the corner frequencies? We have to take the reciprocal of the coefficient of s. So here when you look at this term, what is the coefficient of s here? It is 1. So 1 divided by 1 is again 1 radian per second. Right. When you look at this expression, we are having 1 plus, again 1 by 4 is nothing but 0.25 s, right. So 1 divided by 0.25 will give you 4 radian per second. Now we are going to form the table number 1. So our table 1 consists of 4 columns, terms, corner frequency, slope and change of slope, right. So the first part will consist of constant along with individual s terms. So here I am having a constant 10 along with the individual s term is omega here. So 10 by j omega. Right, and the remaining two terms have to be arranged depending upon their corner frequencies. So here first write the corner frequency. So the value of corner frequency should be written in ascending order. So omega c1 is 1 and omega c2 is 4 here. Right, depending upon the value of corner frequencies we have to write the terms. This corner frequency 1 is given by this term, that is you see this 1 divided by 1 plus j omega. So I had written here. And again the corner frequency of 4 is given by this term. So 1 divided by 1 plus j 0.25 omega. Right. Then when moving to the slope column, you see here this omega is in denominator. So this omega always contribute a slope of 20 decibel per decade. Since it lies in the denominator, here I am writing it as minus 20. Right. And the next step again you see when you look at the second term, here also omega lies in denominator. So this produces a slope of minus 20 again. And here also omega lies in denominator and again this constitutes a slope of minus 20. Right. So the next step we are moving to finding the change of slope here. So to find the change of slope, this first frequency should be shifted downwards and we have to move this frequency to the right hand side. So minus 20 gives you minus 40 and again for the next step this minus 40 will be shifted downwards. So this minus 40 and again this minus 20 gives you minus 60 decibel per decade. Right. And the next step is we have to select two values of frequencies. One is omega L and another one is omega H. This omega L value should be less than our first corner frequency and this omega H value should be greater than our second corner frequency. Right. So here the omega C1 is 1. For omega L you can take any values which is less than 1. Even you can take 0.5, 0.3 or 0.1 whatever may be. So here I have selected 0.1 radian per second. Right. And omega H, you see the maximum value of omega C2 is 4. So omega H you can take a value which is greater than 4. Here I had taken 100. Even you can take 50 or 20 or whatever may be, right? The next step is we are going to calculate the magnitude. So for calculating magnitude, again we have to find the values for these 4 frequency values. So at omega equal to omega L, the magnitude value of A is given by 20 log of 10 by j omega, that is constant and individual s terms will contribute the magnitude. Okay, the initial value of magnitude. So here the A is given by 20 log. From the expression you see, from the problem we are having a constant 10 and an individual s term in the denominator. So 10 by j omega, right? So here 20 log 10 by j omega and the value of omega L is 0.1. So just substitute the values here. When you substitute, we are getting the answer as 40 dB, right? And at omega equal to omega C1, right? Omega equal to omega C1, the value of magnitude is given by again the same formula. Okay, for omega equal to omega L and omega equal to omega C1, you will be having the same formula. So 20 log 10 by j omega, so 20 log 10 by 1, which gives you the answer of 20 decibel, right? So at omega equal to omega C2, you see we are getting the value of magnitude using this formula. So the formula is change of slope from omega C1 to omega C2 into log of omega C2 by omega C1 plus the value of A when omega equal to omega C1, right? So change of slope from omega C1 to omega C2, we have to look at our table. You see from omega C1 to omega C2, what is the change of slope? It is minus 40. So just substitute the value there. So minus 40 into log of omega C2 and omega C1 values are known to us. So just substitute plus the value of A when omega equal to omega C1. That is the previous step, right? And the value of A when omega equal to omega C1 is, so at omega equal to omega C1, what is the value of magnitude? It is 20 dB. So just substitute the value there. So when you substitute the value, finally by solving we are getting the answer as minus 4.08 dB. We can simply round it off to minus 4 dB, right? And the next step is at omega equal to omega h, and again here the formula is change of slope from omega C2 to omega h into log of omega h by omega C2 plus value of A when omega equal to omega C2. Right, so change of slope from omega C2 to omega h, again we have to look at our table. You see here we have taken the value of omega h as 100, right? So while writing in ascending order, your omega h will come here, right? So change of slope from omega C2 to omega h will be this minus 60 will be contributed here. So that is the value we have to substitute. So minus 60 into log of omega h is 100 and omega C2 is 4 and the value of A, the previous value, that is at omega equal to omega C2, the value of A is minus 4 dB. So just substitute the value here and finally by solving we are getting the answer as minus 88 dB. Right. For simplification here I had written the magnitude table, that is in the form of a table here. So it will be easy for us to mark it on a semilog sheet. Right. The next step is we are going to find the phase plot. So this is our given problem. We have just simplified this and this is our simplified format of the given problem. So for calculating the phase plot, the angle is given as g of j omega, which is equal to, here an omega always contribute an angle of 90 degree. Since omega lies in denominator, here I am moving this to the numerator part. So here I have included minus 90. Right, and here this thing tan inverse of imaginary term divided by real term. Here what is your imaginary term? Imaginary term is omega and real term is 1. So tan inverse of omega by 1 is nothing but tan inverse of omega. Again when you move this denominator term to the numerator, I had included a minus sign here. Similarly for the last thing, here the imaginary coefficient is 0.25 omega. So tan inverse of 0.25 omega divided by 1. Again I am moving this denominator term to the numerator. So here I had included a minus here. Right. Now we are going to form our table number 2. So it is mandatory to include all the values of frequencies which we have used to calculate the magnitude. For calculating magnitude, we had used 4 different values of frequencies, right? So it is must you have to include those frequencies here, and even you can include the in between values, higher values, etc. You see, in the previous table for calculating magnitude, we had included this 0.114, right? 14, and finally this 102. I had included this 100. So apart from these 4 values, you can include the middle ranges also, middle range or even higher values. Okay, it is up to you. When you have minimum of 7 to 8 values of frequencies here, you will be getting a more accurate phase plot. It will be very easy for you to draw. That's it. Right. And the next thing is here the terms are tan inverse of omega. So make a column for that. And tan inverse of 0.25 omega. Again make a column. And finally we have to calculate this phase angle pi. So write it over here. Just using a calculator, just substitute the values and write down. You see tan inverse of omega. Here the omega is 0.1. That gives you this answer. And tan inverse of omega, the next step is 0.5. So tan inverse of 0.5 gives you this answer. Right. Likewise, you just substitute, find out the values. Finally, substitute it in the formula for the phase angle and you will be getting the answer like this. Right. So this is our this is our phase plot for the given problem. Just solve by yourself and finally you can check with this. So today I stopped with this. Hope you people understand the problem well. If you have any doubt, feel free to ask me in the comment section. In the next part, we will draw it in the semi-log sheet and we will check how the system looks like. Thank you.